ส่งเข้าแล้วลองเข้าเบิ่งไปนำเวลาเจ้าอธิบายโอ้มันนี่เลย
มาแล้วนี่มันจะติดป่ะ
กับพอดีมัด2 แก๊ส
เดี๋ยวเริ่มคุยกับผมเก็ตโตตลอดมึงแก้โตเลยก่อนเก็ตโตก็เป็นโมง
7 โมงบ่มานั่นแหละ7 โมงนี่แหละกับโมเดลผมกินไวแดงเลยบอก7 โมงนี่แหละน้อยเนาะ
Recording in progress.
istiqlal manası var.
İstiqlal o. Onu pasın değil.
O istiqlal करना पड़ेगा विचार
İstiqlal o.
कोई तो यही थे तो भाई था ना ये स्टैंड को पता है स्टैंड को पता है
Okay, good morning, everyone. So I see a lot of energetic faces there. Anyway, I'm still sleepy because it's like 5:30 in the morning. Yeah, so today, the 4th day of the workshop, we will be talking about the network monitoring and doing the measuring thing for test the performance of your network. So last 3 days we were discussing about the security and every other details of the secure network. So today and tomorrow we'll be focusing on the monitoring and the performance side of the networks. So normally we do workshops in two ways, maybe 3 days for the security and maybe 3 days for monitoring and performance stuff. But in this case, we are trying to mix these two into a single workshop and then to try to come up with something useful for everyone. Okay, so today maybe before the lunch break, I'm trying to get some group photos from the session. So at the time, if it's possible, please try to switch on your video and then we can get your face onto the group photo as well. And then again, just reminding what Tain asked us to let you know is they require you to keep your video switched on during the workshop. That's for their auditing purposes, whether you actually participated in the workshop or not. So yeah, so if you have the possibility of switching on, please do that. And then okay, so I will try to go with few of the slides that we have done for the Learn community very recently, and I will be just repeating the same procedures most of the time on network monitoring. So like 3 months ago, we did a network monitoring full workshop for Learn members. So I will try to reduce the content of that workshop and then give you some of the main things that what we need to do. So basically we will be today we will be looking at things like what you should do with the network monitoring, and then what you can do with monitoring systems. So in this case, I'm going to target on LibreNMS. So LibreNMS is being used heavily in the community. So you can use it free of charge if you are not already using any network monitoring tool. So the older networks, they might be using something related to CACT or maybe something with Negios, but nowadays most of the time we use something like that for if you are very much into the programming side. So for example, you know, CACT and Negios, they have a lot of configuration details. So in case of installing that and maintaining, it will be very much difficult. So because of that, people tends to go into different easy methods. So LibreNMS is one of the such softwares because they have a lot of community, and then the community will do a lot of changes if anyone needs to do. So it is one of the easiest way of doing that. Okay. Yeah, so let I start with the presentation. Okay, so for those who were in the Learn workshop, they might have already seen these slides. So So what we will be focusing here is the monitoring of the network systems, and then let's see how we are going to do that. Okay. So in simple terms, what we will be looking at is like what you need to monitor and why we do the monitoring. So what is monitoring, what to monitor, and why to monitor is kind of the three things that we will be looking at when we are dealing with the network. So why we need monitoring will be the main question for some of you if you are thinking whether what this system does or what this system means. Okay. So for monitoring tools, we'll be looking at different tools. So there are a lot of tools in the market. So the traditional things like Cacti, Nagios, Isinga. So actually, those three are heavily used in the large scale. So if you know how to deal with Nagios or things like Isinga, I'm not asking you to go with LibreNMS. Please go with whatever those other tools that you already have. And then what I have listed here are mostly open source content, free to use. But there are a lot of other commercial softwares as well. So if you have already using some of the commercial softwares, and if you are familiar with that, please go ahead with those software as well. Only purpose of having a workshop like this is to educate you on how to do the monitoring efficiently and how to make it useful when you are doing some troubleshooting. So so the tool doesn't matter. Only thing which matters is whether that tool is used efficiently on your scenario. So that is the main thing. I'll just go back to the first slide. So here, what we will be monitoring is mostly your infrastructure devices, things like switches, routers, maybe the server availabilities, even the environment, maybe the temperature, maybe the whether the physical doors are locked, things like CCTV, whether they are working, and then different other services like web, DNS, emails, etc. So these are the things that we will be monitoring. So if you are running a monitoring system, then you should be able to at least monitor whatever the things that I have already listed on the middle part of the slide. So why we need monitoring? We need to do the availability check for devices. So if you are running an IT department, if you are doing the network administration, if you are doing the IT administration, then you should know about the availability of your systems and then your whatever the devices. And let's say if you are an administrator of a big campus, big university, then there will be a lot of devices, there will be a lot of users, there will be a lot of services, and doing it manually, monitoring them manually won't be possible. So there should be some sort of automated system that automates every monitoring aspects, and then give you the alerting if something goes wrong. So the monitoring will help you to do check their performances, as well as to figure out whether there are any outages or issues in your system. So that is why we are going to do monitoring. So these are some of the monitoring graphs taken before COVID. So you can, if you zoom into the slide, you might see the actual dates as well. So these are some of the traffic graphs that we are seeing using using SNMP, and then these are for our view, our means from the learn view or the research network side. But when you are going into the institutional side, you might have different graphs, or maybe you might have graphs for different faculties, different departments, or maybe different buildings, maybe into different floors. But you can go into the similar graphing mechanism. So in this case, this is kind of a custom-made CAT-T graph, but you can do the same with other tools as well. So then this is again the availability, checking the availability of the devices. You can see what are the available and what are not available. So almost all monitoring tools, they provide these availability graphs. So this is CAT-T, and you can do the same thing with every other tool in the system. And then this is two different views from CAT-T. One is the traffic based on SNMP, and the other one is the latency of ICMP or ping. So these monitoring tools, you can check the traffic as well as the availability and the latencies. So this will help you to identify different things. For example, you can see there are high latency marked in the graph, the yellow color thing, when there is high traffic monitored. So if you can see during the daytime of Thursday, there are high traffic around 800 M in that particular link. And since this is a gigabit Ethernet port, you can see some high latency during that same time. So, but in the morning time, you will see less latency. So it's actually 2 milliseconds as an average latency, but when it comes into the daytime, it goes high up to like 6 or 8 milliseconds. Then this is again something called the weather map. So this is something we used at Learn, and just to see the availability of the links and the other routers that connects into different networks. So weather maps are there in many other systems, but it have to be correctly configured. So in this case, the Learn weather map is kind of done on top of CAT-T. So this is the traditional weather map, but I'm not going to ask you to create these things because most of the time softwares like CAT-T are now outdated. There are different other softwares where they have different other ways of doing the same thing. So yeah, it depends on the what system you use. Then this is the LibNMS, where you can get the same thing in in a single location. So you can see a lot of availability graphs. They call it availability map. And then you can have a summary on different monitoring devices, and then you can get the top devices, different widgets as well. So it depends on how you configure the things and whether you do the monitoring actively. Okay, so there's a question called asking, in terms of monitoring, does that require different tools or approach for SDN? No, actually, in terms of monitoring, there's no difference whether you use a physical device or whether you use a software device. So it will be just you testing the availability of your links and the usage of your links. But if you are looking at the management part of the SDN, then it will be a service in your monitoring system. So still you can use the same monitoring system to check the service or check the availability of the management of the SDN. So it depends on what system you use. For example, let's say if you are using Open Daylight, you can create a monitoring service to check whether Open Daylight is running or similar. So it depends on what service you use, what SDN type you are using. So basically you will be monitoring the SNMP of those devices. So it doesn't matter whether it's SDN or whether it's physical. Okay, so then you might need to have a different location called Network Operations Center. So the why you need an NOC or Network Operations Center is, if you are doing active monitoring, if you have a particular staff for that, you need to have a single place for all of you to have to be on the same page when you are doing things. When you are doing, let's say you are doing a troubleshooting, then everyone that involved have to be in the same on the same table. Otherwise they will do different things and ultimately your trouble will increase, because people doing different things without knowing what is the actual issue. So for that you need to have a single location for everyone, and then you need to have a coordination with everyone, the correct or the proper coordination with everyone. And if you are doing the active monitoring, you can use multiple screens, multiple big screens, and if you have a large number of devices, you can do nice graphs on those screens to see whether there are any issues in your network or whether there are any problems in the system. So that is one other thing what you can do with NOC. So apart from your normal day-to-day work officers, you can have a different location called NOC. So there can be a permanent staff who works there, or maybe you can work there permanently. And then whatever the thing you are doing NOC, one of the main things will be monitoring the network. So it will be one of the key things when it comes into troubleshooting. Your monitored data and your whatever the performance measurements of your previous networks will be good when it comes into troubleshooting. Okay, so the monitoring topology, it will be like there will be some monitoring server or maybe servers. So it can be either a single server or it can be different servers based on your network setup. So mostly we can have multiple setups if you are doing multiple monitoring tools. What I advise is not to put different tools in the same server. Otherwise, you have a big server. Again, don't go with virtualization when you are doing the monitoring system installation, because most of the time, because of the virtualization effects, monitoring tools might not work properly. So try to go with bare metals if you are going to do monitoring servers for large number of devices. If you are just trying to monitor few devices, like less than 10 devices, then it doesn't matter where you install your monitoring tool. But things like LibreNMS or there are different monitoring tools that use a lot of heavy data caching, heavy data processing. They might need bare metal devices without going into virtual machines. So try to go with bare metal devices or a physical device for a monitoring tool. And then if the tool is a big system that do all the stuff for you, then install that along, install it separately from the other tools, because it might need a lot of RAM and processing power to do whatever the monitoring that it does. So keep that in mind when you are installing, if there are no any other monitoring tools currently running. Again, if you are currently running multiple monitoring tools in the same server, please consider moving them into different servers, because at some point you might face difficulty because of having all the things in the same server. Again, the redundancy of the monitoring system. If you run all these monitoring stuff in a single location, then you will have some issue if something goes wrong with your monitoring system. Let's say a failure in your physical monitoring server, then the whole system will go down. So think about those as well when you are dealing with large networks. So traditionally, these monitoring servers will be in a management VLAN in your network. So it can depend on how you do your network design. Better to go with a management VLAN, or at least a different VLAN separated from normal user traffic. If you allow normal users to be on the same monitoring VLAN, then what can happen is if a particular user runs some sort of a scan, or maybe some promiscuous mode enabled software, then they might receive all the monitoring data that you are utilizing. So it won't be a good thing from the side of the security of data. So if you are monitoring something, that means you are checking the availability of that device, and it won't be a good thing to leak those things into normal users. So make sure this is done on a different or a separate VLAN. So it will be on top of the system, and then it will just this particular management VLAN will be everywhere on your system. Only thing is, this particular VLAN shouldn't, if you are not checking the end users, if you are not monitoring the end user connectivities, then you should not go until the end user. So you can just simply stop at your whatever the layer 2 device, at the access level, without opening this particular VLAN to the users as well. But if you are monitoring the end users means the devices like PCs or Wi-Fi devices, mobile devices, then you have to bring this VLAN into the end user level as well. So it depends how you design your network as well as what you are going to monitor. So some of the examples, routers, switches. Okay, so for switches, those switches have to be manageable switches. Otherwise, you can't easily monitor them. Manageable means they should have at least an IP address. So you can just remotely connect to that and check whether they are working or not. So most of the layer 2 manageable device will support the monitoring tools. Definitely layer 3 devices will support, but when it comes into layer 2 devices, layer 2 device should be a manageable device. So normally when designing networks, we ask mostly not to use unmanageable layer 2 devices in your networks, because it's very difficult to manage things when it is unmanageable. So if you have a lot of unmanageable devices, try to remove them from your network and install a manageable switch, manageable layer 2 device in your network. So it doesn't matter what vendor you are using, what type of device you are using, it should be a manageable device. So whether it's a Cisco device, whether it's a HP device, it doesn't matter. It should be a manageable device. And then servers, you can monitor the server availability as well as different aspects of the server, maybe the heating, maybe the power consumption. So likewise for the servers. And then different other services running inside a device, maybe a server, maybe a switch, but there can be different services, different apps. So services in the sense like HTTP, SMTP, NTP, likewise. Then there can be different sensors, heat sensors, proximity sensors, a lot of things, even the security doors, IoT, different IoT mechanisms. Even the CCTV can be part of your monitoring topology. And it depends when you go into the end user devices. So whether you want to check the end user devices. Sometimes, let's say if you run domain devices, domain PCs, then you can use the monitoring as well, because you need to know what are the PCs that are working and what are the PCs that are not working. So that is if you are dealing with end user devices. So how to monitor? Mostly it will be based on SNMP if you are trying to see the traffic monitoring. But most of the systems, they use different methods. One is just SNMP, but it is not always SNMP. And then there will be ICMP as well. So depending on what monitoring tool you use, it can be configured based on their the way how they use. So for example, if you use some commercial product, they might give you an agent that you need to install in the on the system what you are monitoring. So it depends on the system. So SNMP, ICMP, or any other tool that will provide the monitoring. Then if it's SNMP based monitoring, there will be two things, SNMP server and SNMP client. In this case, the the monitored devices, routers, switches, they will be the SNMP server, and your monitoring system will be the client. So your client will try to get details from your SNMP server. I'm not going to go into details of SNMP because it will take a lot of time to explain what is SNMP and how SNMP works, but those are some SNMP means how they work is something traditional, so you can always Google what SNMP means. So SNMP is how we use how we poll the traffic from the system, or how you poll the availability of the system from most of the devices. So mostly all the routers, all the manageable switches, they come with inbuilt SNMP capability, so you can use that. And again, you can use SNMP on different other servers as well. So for example, if you are running a Windows server, you can enable SNMP service on the Windows server, and then you can monitor the Windows server from SNMP. Then there's something called agent-based monitoring, where you install an agent in your system. So for Linux-based networking devices, you can do this. But in the traditional networking devices, things like traditional routers, traditional switches, you might not be able to install agents. So for those devices, it will be just SNMP and ICMP. But if your device is running explicitly on Linux, sometimes you might be able to install these agents on the network devices as well. Or otherwise, there will be agents for all the guest OSs in servers. So whether it's Linux, whether it's Windows, whether it's something else, there will be agents if you are using an agent-based system. So what this agent does is it will poll the monitoring aspects of the particular installation, maybe the traffic, maybe the availability, or maybe the utilization of different resources of the server, and then it will send those data into the monitoring system based on a predefined interval. So it can be a 1 minute interval, or it can be a 1 second interval, or sometimes it can be real time, depending on how you configure these for your system. Okay, any questions? Any questions on why we need to monitor what we are doing? All right, then yeah, so there are some there's a question asking how to configure alerts in LibreNMS. I will go into that during the installation. What is the best monitoring system? Yeah, so we do LibreNMS because it's easy for the installation and it's easy for teaching how to do monitoring. But if you ask what is the best, I'm not sure LibreNMS will be the best solution because it might use a lot of let's say your resources to do the monitoring. In that case, I would prefer still the systems that use Cacti and Nagios because they are very less weight. But the thing is, you should know about your system before you are installing such service. So if you have done monitoring for some period of in your network, then you should be able to get all the insights of your network. Then you can simply go into a advanced system. So recently we introduced Isinga 2 for our learn people. So you can actually you can check our workshops. The previous workshop we had in, I guess, in April or May. We were using Isinga, and there are a lot of Isinga helping materials how to do the monitoring. So if you are interested in doing that, you can simply check that as well. So Isinga is kind of an advanced configuration, and it requires a lot of insights in your network. So that's why we are going to go with LibreNMS, because LibreNMS is just install and then give the IP address to the device. So LibreNMS will do the rest for you, like finding the service, finding the maps, creating maps, everything. But if you go with something like Cacti, Nagios or Isinga, then most of the things you have to do it manually. So yeah, so I can't exactly say what is the best, but yeah, many people use Nagios, Cacti, and Isinga in this regard. So then NetX XMS, yes, it's again should be a lightweight installation, but I'm not sure how it will work with a lot of devices. Sorry, I haven't used it for a longer time. But I think it's still open source, so yeah, you can use that as well. And then can you use pfSense as pfSense? You can't actually do the network monitoring because pfSense is kind of a firewall, just going to do the traffic shaping or filtering, but you can do some monitoring on the traffic that you are dealing with. So pfSense, it will be just looking at the traffic that you are flowing through your device. And then if you want to monitor different other devices, pfSense won't be the ideal system that you should be using. Any other? Okay, so then we will go to the other item. If you go to the our agenda, there will be a link called LibreNMS under this session 2. So I'll be using the same guidelines that we did for Learn Community a few months back. So this is the same guideline for that installation. We were using Ubuntu 20.04 LTS for the configuration. So the case with Ubuntu 20 Ubuntu versions is like they might change the way how they work on their LTS versions. So if you have installed LibreNMS on Ubuntu 18.04 earlier, then it might not be the same way of doing it in Ubuntu 20.04. So there will be different changes. And then we'll be installing this on top of Nginx. So most of you might have been using Apache, but in this case, we wanted to try Nginx. So if you are not familiar with Nginx, you can simply remove the Nginx part and then apply it on Apache. So it doesn't matter. These commands we are running on as sudo as root. So for the lab, you can become root by applying sudo su or sudo su on Ubuntu. I will just quickly explain the procedure. So first you need to do some of the dependency updates. So these dependencies should be installed in your system. So I will, so for the lab, for the workshop, if you are installing this lively, it doesn't matter what configuration you use for your VM, but better if you go with at least 4 GB RAM. But in the production scale, try to at least go with a 16 GB RAM device, because you will be monitoring multiple devices. So the thing is, if you are just trying to monitor 1 or 2 devices, you don't need actually a monitoring system, because it will be just 1 or 2 devices. But if you are installing a monitoring system, means you are going to monitor a lot of devices. So it will need a lot of monitoring a lot of devices will require a lot of RAM. So better to go with at least 16 GB in this case. So at least 16 GB RAM and then at least 500 GB hard disk. And it's better if you can go with the at least i5 computer if you're not using an actual server. So the thing here is you can simply get an i5 PC, i5 or i7 PC, and then install Ubuntu and install these things on top of that. So that would be the ideal case if you don't have the resources or if you don't have the server space. Okay, so then you need to create a different user for LibreNMS. Then in this example, in this tutorial, we'll be installing LibreNMS directly from GitHub, or otherwise there will be other sources as well. So what we'll be just doing is getting a clone from the GitHub and then installing it. So it can be done in the way of this. And then for LibreNMS, there will be several dependencies on PHP, because LibreNMS will be the website of LibreNMS might use different PHP dependencies. So you can run these things. And then one of the main thing you have to do is you need to make sure your PHP versions and your server time are the same. So for PHP, you have to edit these two files and change the time zone. So in my case, I'm using Asia Colombo, but for you, you can use your own time zone. So time date, CTL set time zone, and then Asia Colombo will be the Ubuntu time date control setting. And then this will be the PHP setting for whatever the time zone you are using. So why we ask you to do this is, if you don't change the time zone, this installation will default to UTC time, and it might make you difficult to identify the times of the monitoring issues. So for example, if you want to do some sort of a troubleshooting, then you should know the actual time on your time zone, not in the UTC time. So try to change the time zone before starting everything. So this doesn't apply only to LibreNMS. This will apply to all the other monitoring tools as well. Make sure you do the monitoring on your time zone, not in UTC. Unless you have monitoring devices everywhere around the world. If you are not good, if you're not in different multiple locations, if you are in the same country, then go with a single common time zone. And if you don't know about your time zone, you can just go to this PHP link, and then php.net link, and then you can find your time zone from there. Then we'll be using MariaDB to do the database installation, and then these tables need to be created. The MariaDB users need to be created, and the database. So for the installation, we'll be using a database called LibreNMS and a user called LibreNMS with the password, just for the simplicity. But in your actual installation, if you are running a production level installation, please change this thing into something into an actual password, not to some common word. So for the simplicity of the tutorial, we'll be using this word, but in your production, don't use this word. Then some PHP based configurations, and then the web server configuration. So this is for the Nginx, but if you are running the Apache, then make sure you put this as the web root and whatever the server name you want. So in this case, we are just putting some example DNS value. And apart from that, there won't be much changes. But if you go into LibreNMS website, they will provide you LibreNMS documentation. They will provide you the Apache configuration as well. So this is for the Nginx. Then the installation of LibreNMS, you have to create those symbolic links and then the scripts, configure SNMP service in your server. So this is how you configure the SNMP service. And then there will be a lot of cron jobs in LibreNMS. And log rotate. Once you do this, you have to give the permission to the web installer. So this installation, the basic installation will be done on the web-based system. It need to be included in the LibreNMS user. And then you can again run something called validate PHP. So this script will give you all the troubleshooting if you needed with the installation. Once you do that, if you don't have any issues, you can go with the web installation. You can just type in your IP address or the domain name, and then these settings will pop up. You just have to click next and then give the database details. Basically, it will be localhost for your host since you will be installing it in the same server. And the username and the database name and the password. Once that is working, you can just click next and then create an admin user for the system. So in this case, I am asking you not to create a admin user with the name admin. So your admin user should be something else. Don't create a user called admin, because having a common username is not good for a monitoring tool. So once you set up this system, if this system is publicly available, some people might try to get into your monitoring system. Someone might try to hack into your monitoring tool. So one of the easiest ways is to brute force the password. So if you use common usernames, it will make them easy because they know the username. But if you do a different username, still don't use your name, because if it's an insider attack, your users will know who's doing the monitoring, so they will know your name. So try to use something different. And then a password and your email address. The email address will be used to send you different alerts. So make sure this email address is a working email address. Then once you do the installation, you will see this login page. And then once you log into the system, you can add devices by just clicking the add symbol in the dashboard and then on the menu devices, and then giving the IP address or the host name of that particular device and the SNMP details. So mostly you just have to include the SNMP community in this location and it will work. Okay, shall we continue? Shall we do the lab? And if you have, while you are doing this, if you have any issues, just ask me. So if you are good in Linux, this installation shouldn't take much time, except for the downloading speeds and the processing speeds of the system. I'll try to keep like 15 minutes for this installation, and then I will explain the other part of the installation guide, the alerting part. So you can simply go into the alerting as well. Yeah, so let's take like 10-15 minutes for the installation, and then I will explain the alerting as well. Then, yeah, thanks, Pema. So, yeah, I'll share the attendance sheet.
Tilna, are you there?
Yeah.
Can I ask a question regarding the monitoring things?
Sure.
All right, Tilna, I'm looking for a solution for SDN, and I'm a newbie for the domain as well. So I'm looking for not the network monitoring part, but the traffic monitoring part of the SDN. So can we use the basic setup of the things that we are using in the campus network monitoring setup? All those things can be added to the SDN. Will it work? Or is there any other kind of solutions for the SDN specifically?
So I'm not sure whether this LibreNMS can be useful for such thing, because yeah, it won't be using SNMP. Then I can't exactly give you an answer because I haven't used that, but sometimes Isinga might help you.
Okay. I think Libra and Isinga both monitoring the network infrastructure, no? Not the traffic overflow.
No, so yeah, so that's the thing. So LibreNMS doesn't support, but Isinga it can be associated with flows as well. But in case if you only look for flows, then I might suggest the ElastiFlow. Yeah, I guess you know that ElastiFlow. Yeah, ElastiFlow, or otherwise the flows with
you mean the S-flow kind of things?
Yeah, I forgot the name of the system. Give me a second, I'll just check it and see. Prometheus.
All right.
Yeah, so if you are looking for open source solution, Prometheus will be the best solution. But I'm not sure about the configuration, because it might not be easy to do the configuration. But if you go with ElastiFlow, configuration would be fine, but there might be some licensing issue if you go into 1.6, 1.5 G traffic.
Okay, thank you.
Okay, so I'll try to explain the alerting part because we are like running out of time. So the same agenda page will have the alerting link as well. So this is the alerting, how to define alerts on LibreNMS. So once you install the LibreNMS, you will see a menu called alerts on your installation. Go to that, and then there will be something called alert transports. So sometimes this might become a little tricky when you are configuring alerts on LibreNMS, and it will, if you don't do it correctly, it won't send any alert at all. Again, if you do it correctly, it will send you a lot of alerts every time when it detects something. So you need to be very specific when you are installing this. So one of the main things you need to do here is, first you need to create the email setup. So this email setup, you can use either your own email server, or inbuilt email server on the LibreNMS. Inbuilt means the postfix or something that you install on LibreNMS server, but it won't be a good thing if you get a lot of issues with email sending and spamming on your domain. So in this case, I would ask you to use your own, use your external email server, and then use the email server details in this transport alerts to set up emails. But in this example, I'm using Google, because most of you are using Google emails. Most of you are on your Google education packages. Because of that, I'll be showing you how to add Google emails, Google-based email account to LibreNMS. So first of all, you need to give the email address of your account to set up this transport. So first we need to create a alert transport. In this case, alert transport means the way how you do the alerting. So it's just a name they use. So don't get fear about the name. It's just a way how you do is, if you have multiple emails, you need to have multiple transports. If you have multiple persons to be alerted, then you need to have multiple alerting lines. So in this case, I'm using an example. So here you see the transport name. I'm trying like email to Tilina, and then the transport type is mail, and then you will put your email address as well. Okay, so first create that alert transport, then you have your email address in the system. After that, you can go into your Google account, and then from the Google account, you need to enable less secure app access, because since this is open source software, Google is not allowing the Google authentication for this email sending. For that, we need to enable less secure app access from your security page of the Google My account. Go to that location and then allow less secure apps. After that, come back to the LibreNMS, and there will be a small settings wheel, the round thing. And on the settings wheel, there's something called global settings. And under global settings, there will be something called alerting. So this is the setup for the newest LibreNMS system. If you are using an older version, if you are looking at some older version of LibreNMS, it might have a different UI setup, but the procedure will be the same. You just have to first set up the email options and then create the transports. So on the email options, you can enable the email alerting, and then you can add the email address. So from the email address, whether you want to customize that. So in this case, I'm using something like this. So actual email address will be my Gmail address, but I'm using an alias LibreNMS. Then I'm going to use HTML emails because HTML emails will be nice and have different things. Then SMTP details for Gmail. Make sure the TLS encryption is enabled and SMTP authentication is enabled. So for the SMTP authentication, it will be your username, the full username with the domain and that password. There are ways to enable password per application on Google, but in this case, I'm just using my Gmail's password since I'll be using my testing accounts. But it's better if you can create a different email address for this in your Gmail and then include it as per the system. So it will be just LibreNMS or whatever the monitoring. But if you're using a common email address, try to set up the application specific passwords thing from Google. So they have something like that. Once you do this, you will see a test transport page. You can just click this symbol and then you can see whether you receive a test email into your email account. One of the other advantages of having Gmail is once the LibreNMS send any alerting, Google will keep a copy of the email in your sent box. So you get to know what emails were sent from your LibreNMS as well. Otherwise, you need to find another log on some other web server, some other email server to find what were the alerts that were sent out. So again, using Gmail or some other web-based email system will help to do any other troubleshooting with email sending as well. So this is the way of how to do the email setup. And then since most of you are using Slack, we thought of introducing Slack as a way to do the alerting on LibreNMS. So this doesn't apply to LibreNMS only. You can use any other monitoring tool as well. So this example is for Slack with LibreNMS, but you can use Slack with other tools as well. So for example, we were using Isinga with Slack. So likewise, you can use Slack once you get to know how it works. So for Slack, again, you need to create an email transport with the type Slack, and then you can decide whether this will be the default alerting method or whether your email will be the default alerting method. Most of the time, email will have the precedence if it is default. So it depends how you should work out your system. So there was a question from Niraj asking whether we can do alerts based on a particular service. So in this case, he's asking about BGP. Yes, you can set up BGP. You can set up any other service So it depends. If you are monitoring a particular service, so in this case, I'm assuming you are directly monitoring the BGP service. So then you can set up a transport, you can set up an alert saying, if this particular service gets down, send an alert to this particular customer. So you need to mention the customer email address as well. So if it's email, if it's Slack, then you can do the Slack, or later we are talking about Telegram. You can use them as well, or even SMS. I'm not going to show you how to set up SMS, but it will be the same. You can just put any API from an SMS provider. So the SMS will, then the alert will go through SMS. So the Slack, you will see the way how you create Slack. So there's something called incoming webhooks. You have to create that. There's an example given in our tutorial. Once you create the webhooks, you have to give that particular webhook URL into the Slack. And then when you do the testing, you will see a testing message from Slack, from LibreNMS to Slack. So here you can see some of the screenshots, how we do the testing. And then same goes with Telegram. So these days people use Telegram heavily. So you can create a Telegram bot for doing this, doing the alerting. So you can read the way how you create a Telegram bot, and we have given the details on how to create these bots. Once you create the Telegram bot, you can simply give the Telegram bot chat ID and the token. There will be two things, chat ID and token for the bot. So that bot can be used to, so in this case, I'm using a group bot where there are multiple people in the group and along with the bot. So whatever the alerting this bot sends, it will go into all the users in that group. So in this case, it have a different chat ID and a token ID. Once you save the transport and do the testing, you will see a test alert on the chat, on the Telegram bot. So it's easy, it's interesting. You can do this alerting from LibreNMS. So it's not, this is again not just LibreNMS, you can do it, do the same thing with other monitoring tools as well. Then once you create the transports, you have to create a transport. If you have multiple transport groups, you have to create a transport group saying this is the transports that you need to use. So in this case, we are using something called transport default. And here the group members of that will be the Slack learn, in my case, and then email to Tuan, one of our members, Telegram Tilina, and then email to Tilina. So you can see 4 alert transport alerts in this group. So if you have multiple emails, if you have multiple ways of transports, you can have a common group. So once you create the alerting rules, you will receive all these alerts for the whole group. But if you need a specific alert to a specific transport, then you can select simply the specific transport, not the whole thing. Okay, so there are a few custom alert rules. Again, once you enable alerting, there will be some ready-made alerts from the LibreNMS. You can use that as well. Then these are some of the custom alerting that you can create. So for example, you can create to check whether a particular PC is down or up, whether memory usage is this kind of. So for the first one, you can give a device name, rule name, and then number of alerts, the delay between alerts, and then an interval between alerts. Then whether you want a recovery alert. Recovery means once this condition matches, it will send you an alert. And recovery means once again it recovers. Let's say if the device is down, it will send you a message. But let's say once the system is up, again it will send you a message in this system. So in here it's like it's testing a particular IP. So this is a host. So in this IP, this is not just the IP, this is the host. So it's testing an IP and then sending an alert to a particular email alert. So in this example, it's the mail alert. So here you can see the string as well. So this will be the advanced string if you go into the advanced tab. So the same way, so this one is for memory pool. Then high CPU processor usage. So these are 3 examples on doing the alerting, but you can change, you can simply even check the templates of the alerting. There are a lot of templates on libnms, and you can see whether they have a particular matching alert, and then you can do the testing. And then for things like Niraja, you have to set up a custom rule specifically saying this should be the service that you are going to check, and this should be the person that you are going to alert. Okay, any questions? So creating alerts, the hard part will be creating the transport mechanism, because the tricky thing is setting up the emails and setting up the other transport mechanism. Once you set up this and once you receive the test alert, then it's fine. You can simply test all the alerting rules. Okay, so before breaking for lunch, shall we take that photo, the group photo? Yeah, so everyone, if possible, please switch on your videos so we can take a quick photograph from everyone, and then we can break for lunch. Okay, I'm going to take my okay, so you can also take whatever the screenshots you like from the group, and then you can share them on your Facebook or Twitter or whatever the social media you like. But when you are sharing, please mention what the workshop is, because 10cc they will like to see these sharing. Okay, then we'll break out for lunch, and we'll come back in 30 minutes, less than 30 minutes. Okay. Okay, good evening, good afternoon, everyone. So I'm going to go through NetFlow session in the evening, and then I'll be introducing you to NFSen NG. So earlier we were using NFSen, the traditional NetFlow collector, but there are a lot of dependencies with the NFSen with new operating systems, and NFSen is kind of an old system that doesn't work with these dependencies. So because of that, there's a new version called NFSen NG, the next gen. So it is not the same as what we had earlier, but something similar. So this will be a good start point for analyzing net flows. And then I might introduce one or two other net flow analyzers based on the time we have. So I was thinking whether to first go with the tutorial and then go with the slides. Okay, so first I will show you some of the net flow examples, then we can decide. Okay, so this is, I hope everyone can see the screen. So this is one of the test installations I did with NetFlow NFSen NG. So this is similar. This is again similar to the NFSen we had earlier, but with little bit more CSS and JavaScripts running in the background. So you can see nice nice graphs and responsive things. So this is NFSen NG, and yeah, so these are some of these. If I do 1 hour graph, you can see the packets, then the traffic. So you can see this is in my browser time, not in the Colombo time. So I haven't set up the time or the time details of PHP. Because of that, I'm seeing my own time. So here now it's like 7:35. So I can see the 7:35 time. Then in my installation, there are 2 sources created, but unfortunately, one is only sending the data, other one is not. Okay, so if I select both, again, we can have the UDP, TCP, ICMP stuff. Then, yeah, so this is the basic graph, and then here is the timeline. So here only we can see the 24-hour thing because this was very recently installed, but you can go up to several years depending on the hard disk space you have in your server. So and generally, if let's say if this was a 10G network, it might take around several gigabytes per day. So I will show you this one. So this is the traditional or the older NetFlow version which we are using for Learn, and here you can see several 10G links, and if I go into details, So these are some of the net flow data that is coming from the live network. So this is in Colombo time. You can see Colombo time, and for this installation, it's taking around. Let's see. It's taking around. Yeah, so it's like 10 gigabytes per day for the whole thing these days. So these days we see less traffic in our networks because of the lockdowns, but still we can collect around 10 flows, 10 gigabyte of flows per day. So if you are running multiple networks, if you are collecting multiple devices, you need to have a lot of hard disk space if you want to retrain data for several years. So yeah, in this example, you can see there's a timeline up to 2 years, but in a 10G network, up to 2 years means a lot of data. So when installing these things, just consider that as well. So in our case, we are only keeping in this one, we are only keeping 1 month or 1.5 months data because we don't have much space to retrain data. So we are only saving these data for up to maximum 2 months. So these days it will be like 2 months, but in full utilization, it will be somewhere around 1 month to 1.5 months based on the utilization. Okay, so this NFSN-NG, I will show you how to install from the tutorial, and then you can do different ways of filtering and finding different things from the NFSN-NG as well. So here you can see the unfiltered list of flows. So this is the aggregation of protocols, TCP and UDP. And then let's say if you want to aggregate based on a particular subnet or a particular IP, then you can select these as well. So for a particular IP like this, particular subnet. So you can do this aggregation as well. So for example, let's select this. You can see the source addresses, source address aggregation. So this is for /24. If I keep it like this. So this is for this /16. The traffic aggregation based on the source address subnet. And then if I go to statistics, you can check the statistics for any of these details. So these are the usual stuff coming from the NFSN or NFDUM. So here you can see IPv6 as well. So this system is capable of ingesting IPv6. So you can use IPv6 addresses as well. So this is kind of a dual stack. So if your device supports dual stack, you can simply use IPv6 networks as well. Okay, so this is the NFSEN NG or the next gen. Then there's something called ElastiFlow from so earlier, so this ElastiFlow is based on Elasticsearch and NetFlow collecting. So earlier there was something called NetFlow module for Elasticsearch, but the developer of that particular module, he started something called ElasticFlow. So this is ElasticFlow. They still provide an open version for this, but it have limited capacity. But still, for small networks, for like let's say 100M networks, this will be more than enough. So you can simply install Docker and then run these things from Docker. So the collection and the analysis will be on Elasticsearch and Kibana based on the ElasticFlow guiding. So this is the collector. So you can simply install this on a server and then set up your routers to send net flows to this particular device. So if you check the system requirements, that will be the hard part for ElasticFlow and any other flow collector using Elasticsearch or any high capacity system. So this will have some drawbacks of having this particular system. So for example, you can see per core, these are the number of flows that can be processed per second. So if you are running a large network like more than 10G net traffic, then there will be a lot of issues. So this is good for something like 100M network. Then the memory, again, memory will be issue for most of the time. So if it's running Elasticsearch and if this runs, so they recommend at least 2 GB, but this is only for the small networks. For networks like NREN, I would prefer somewhere around 32 GB RAM for this sort of a installation. So there are different ways of installing it, and then I install it in Docker or directly on Linux. Then you have to install Elasticsearch. So for Elasticsearch, they say directly it should be at least 32 GB. So your server should have a lot of RAM for this. So make sure that is there before you are installing these kind of applications. But once you install this, it will have nice graphics, and it will have nice nice way of doing the analysis. So these are some of the examples. It's not like what we saw with NFSEN or NetFlow, just NFSEN NG. So the Kibana graphics will have nice forms of presenting them. So yeah, you can, if you want such presentation or if you want such analysis, this will be the best for you. So things like this, even the geolocations based on the IP address. Different AS traffic. Okay, so this is Elastic4, but I'm not going to go into how to install Elastigirl, we will be looking at installing NFSN-ng. So this NFSN-ng installation is on the last link, the session 4 NetFlow link. If you go there, you will see the installation on Ubuntu 20.04. So why we install an NFSN-ng is the traditional NFSN doesn't support the newer operating systems. It will have a lot of dependencies. Because of that, we will be installing NFSN-ng. But NFSN-ng is depending on another package called nfdump. You have to install nfdump on the operating system. There are several ways of installing nfdump. In this case, I'm using the GitHub version to do the manual installation, manual compiling and installation, because we need few additional things to run NFSN. But if you are so in this case, NetFlow is something comes with Cisco, and today NetFlow there is a common standard, but some of the other devices, like for example HP devices, they have something called SFlow, not NetFlow. So if you have a device like SFlow, then those flows might not exactly work with NetFlow collectors. So because of that, you need to compile your nfdump to do the SFlow ingestion as well. So for that, we need to do it manually. That's why I'm using the compiling by manually, and then we need to look at the router configuration. So in this example, I'm giving you some router examples for Cisco and HP, but if you have a different router, again, even for Cisco and HP, this example might not be the actual for every model. So you have to check with your model and your operating system and your vendor whether they support NetFlow or or SFlows. So when I go with this example, first we need to install some of the dependencies, and then you can download the GitHub or you can clone the GitHub of nfdump, and then you can follow this setup to do the setting up of nfdump in your device. Normally for the lab, I'm okay whether if you install this on the same device that we were configuring libnms and other stuff. But in the actual scenario, don't install libnms and NetFlow collectors on the same device, because the NetFlow analysis will take a lot of RAM and a lot of processing power, as well as libnms will take a lot of RAM and processing power for its libnms own services. So make sure if you are using both of them, make sure to install them on 2 different servers. Then these are some of the Cisco configuration as well as HP configuration. I'm not going to explain these things, but the bottom line of this configuration is on whatever the router whatever the device you are configuring, you need to first set up something called NetFlow exporter. So you need to provide the IP address of the NetFlow collector device and then the port number. And then you need to map that into a particular interface or multiple interfaces, saying this interface will be exporting data, exporting flows into that particular collector. And then you can define what type of flows that you are going to collect, and whether you are going to collect input flows or whether you are going to collect output flows or both. So in this example, you can see I'll be collecting the both sides going in and going out. Otherwise, I can't find who went in and who went out. So this is for both IP and IPv6, and the same thing for HP. And then once you do these changes in your router, then you can check whether you receive these data from into your server. So first thing, install nfdump in your server and then configure your router or whatever the NetFlow capable device. It can be a router, it can be a layer 3 device, or it can be a firewall, or even a pfSense. So in pfSense, there's a plugin called Flow. I'll get into the pfSense plugin later because I just forgot the name. pfSense, they have a plugin which supports NetFlow exporting. You just have to install the pfSense plugin on pfSense and then give these details to that. Then it will support, it will send you all the net flows. So for example, in this case, these flows are coming from a pfSense. Then from the server side, you can test whether you receive these data by running some command like this. So the capture for NetFlow is called NFCapD, and capture for SFlow is called SFCapD. And here you can see a port number, -P is the flag for port. So here the port should be equal to whatever the port you mentioned on the router, the transport UDP port or the port on SFlow collector. So in this example, we are using 9001 for the port, but later on I will be changing those two ports into two different ports. So basically, if you have 10 devices sending net flows into your collector, ideally you should have 10 different ports listening to those devices, because it will be the easiest way to differentiate traffic, differentiate collected data from each other. Otherwise, all the traffic, if you use the same port for all the routers, it will be on the same folder, on the same with the same file. So you won't be seeing much difference from the traffic because of that. So if you have multiple devices, then use multiple port numbers with multiple instances of this. So for example, you can run this for the first device, and you can change the port number, let's say 9002, and then change this folder into something different, and then you can rerun the same command for the second one. So this is some way of testing whether you receive net flows and S flows. Then before setting up the NFSend, you need to set up few things like where you download the data, where you install the application, how you run the NFCapD or sfcapd. So in this case, I'm showing you an example for two devices. So I'm putting a name called source 1 for for the device 1 and source 2 for the device 2. So the location for source 1 data will be this one and source 2 data will be this one. Once you create these locations, you need to give permission to your Apache user, because NFSen will be running on Apache, and it should be capable of reading these locations. So I'm giving the root location the permission. If you add an additional folder later on, again you need to rerun this command. Otherwise, your process will be dropped because of the permission issues. Then I am going to run two instances, one for NFCap and one for SFCap. But still, if you have two net flows, this can be another NFCapD. So it doesn't matter. Only difference should be the port number and the location where you save. So here you will be running NFCapD as a daemon listening on port this 9995 as the user of the web server with these settings, and then I'm giving two names, source 1 and source 2, for these two particular systems, and then having a setup of source 1 and source 2 on a different location. Then once you run these two commands, you can run a netstat -nlp on your system and see whether these two ports are listening. So these are daemon mode commands, so they will just run, and then you might not be able to find whether they are running. So the best way is to run this command and find whether these ports are open. If you can't see these ports, open ports, or especially open UDP ports, then tail syslog. So you will see if there are any error in the service. Most probably you will, if you have any permission errors, most probably you will see errors on the syslog file saying you can't, the termination of NFCapD due to permission errors. Once these two start listening, you can start installing NFSen. Okay, so there's a small thing here, just ignore that. And then these commands are, I just copied it directly from the NFSen ng installing script. So again, it will require several packages like PHP. You can, so for Ubuntu 20.04, they are using PHP 7.4 and some Apache modules, Perl modules, and then few configurations on Apache configuration, and then you need to so this NFSen ng is HTML or PHP based application. So you need to first go into the root of the web system. So in this case, for Apache, it will be just www.html if you haven't changed that. So I'm using the default location. Go into this location and then get a clone of this link. Then give the permission for www data. And again, there will be an executable PHP file called cli.php. Make sure you give the configuration, the executable permission for this CLI PHP. I will explain what is CLI PHP in a minute. Then you need to create a configuration file for NFSN. There is a sample file. You can get a copy of that, and then you need to edit it. So there are sample settings already on that file, but now you need to edit it as per your configuration. So this configuration will, so for this example, I'm using two sources here. The source names are source 1 and source 2. Make sure you put the same names there, because they need to be case sensitive and exactly as per the name here. All right. So there will be something existing. You just have to change that value. So in this case, I'm using 2, but if it's just 1, you can simply remove the second one, and you can simply add your whatever the name you are using. So for example, in our learn NFSN, we are using different source names. So these are some of the source names that we identify. This is the way how we identify our router links. So you can see NKN. So GS means the global switch in Singapore, and then there's an IX link, and then there's there are 2 internet links. So this INT means internet. So likewise, you can define different names for these sources. So it doesn't have to be source 1 or source 2. You can add whatever the name you like. And then NF dump settings, you need you might not need to change these things. It will be the same as it is, but make sure you double check the location of this profile data. So it should be live, and then the location of the profile data. So this location would be same as this location. And this particular folder should be equal to this. So there can be multiple profiles, but in this case, still it doesn't support multiple profiles with the NFSN-ng, but the earlier version, the traditional version, they supported multiple profiles, but still NFSN-ng only supports a single profile. Once you do this, then you need to import whatever the existing data that was saved on that particular location, the earlier location, to the NFSN system. That is done by running this command. So now here you can see the cli.php. So you run this PHP command in Ubuntu with the flag, with the import flag. So it will import whatever the existing data on those locations where you mentioned here. So it will read the location, and then it will get these data to the system. So if you run this import command in an existing system, if there are like a lot of net flows already saved, then it might take some time to import all the data. So if you are running it on a existing system or on a system where it have a lot of existing net flows, make sure you have you give some time for this script to run. So for me, I ran that for like 5 minutes for the existing data, for example. Okay, I don't have a screenshot of that. All right. Once your import is finished, you can start the NetFlow daemon, nfsend ng daemon, by running this command. So this daemon, what it does is it will run a similar command every minute, but it will be automated. So your NetFlow and your nfsend installation will see traffic continuously. Otherwise, you need to run that import command every time you need to read something. So once you start the daemon, you will see a message like this daemon is running in your nfsend-ng folder. Okay, so this is the way how you go into the nfsend page. You can just put your IP address and then go into that location. The standard nfsend-ng or nfsend, both of them doesn't come with the security mechanism. So you can harden your security by introducing HTTPS to this particular installation. Put a DNS value here, then HTTPS, and then you can use some Apache-based authentication system, maybe a browser-based authentication system for this particular location, nfsend-ng. So the basic Apache authentication can be used to put a username password for this system. Otherwise, if this system is publicly available, everyone can see the traffic that you are getting. So it won't be a good thing for allowing everyone to see what you are receiving and what you are sending. Then, in case of a server restart, the previous commands will not work again. So for that, you have to rerun these 3 commands. So it will simply ingest all the traffic again. So what you can do is you can simply put these 3 commands in a bash script and then put that bash script on cron job to run on every reboot. So it will automate the script. And then I linked several references. You can just read and see more details on this. So this is regarding nfsend-ng and not on the normal nfsend. So I'm not going to go into normal nfsend installation because it's time consuming and it's difficult to do it on newer operating systems. Okay, any questions before going on to going into the slides? Okay, then I'll go to the slides. Mhm. Okay, so net flows, most of you might know already what is net flow and why we collect net flows. So it's all about analyzing what traffic you receive and you send, and then we need to do it while preserving privacy. Since there will be someone who might not know what is net flow and what you can do with net flows, I will just go through these slides. You can see these things, privacy concerns. We have a lot of privacy concerns, and then the traffic analyzing with UTM devices, so on. Okay, so how to do it? Can be done with net flows. So net flow was originally designed by Cisco, but today it's kind of an open standard. Using net flow, you can characterize traffic, and then again you can account these traffic on how it went and where it went, and then you can use net flows to do the network investments, network planning, traffic engineering, even usage billing. So sometimes this SNMP might not give you the proper usage of a particular system, but with net flows you can simply do a proper billing if you want to do it for your customers. So that is another advantage of having net flows. Then net flows, it can be just scalable, manageable, reliable. I'm just quickly going through some of these stuff because there are like 50 slides and I don't have much time. What is a flow? So a flow means a request or a data coming from one source to another destination. So in this example, you can see a request flow and a reply flow. Computer A is running a web browser and computer B is being the server. So the request will be something like the one with a random port number and then to the standard port of the destination. And then the reply can be something from a standard port to a random port, standard port to a random port number. But this is like HTTP traffic, but it depends on what traffic that we are looking at. So it can be two random ports if it's a randomized traffic transfer. So for all the standard traffic like HTTP, HTTPS, FTP, Telnet, SSH, DNS, all these protocols, they have their own port number unless you customize them. So simply you can identify these data whether they are HTTP or whether they are HTTP or something like that. So this is the same thing most of the UTP devices do. It will just look into the flow of the traffic, and then it will categorize that data. But in if you are not using a UTP device, you need to know how to do it from different other ways. So NetFlows will be one of the sorry. So NetFlows will be one of the ways you can do it. So another example for bidirectional flows, you can see 6 flows with different IP addresses. Can you identify the flows? So you will see you can identify these by the protocol. The first 4 are TCP, the second are UDP, the protocol number 6 and 17 are for TCP and UDP. Then you can see the first 2 as a request and a reply. Last 2 again as a request and a reply. First one HTTP using port 80. Second one, the last one DNS using port 53. The middle one, the third and fourth flows, they are like request without replies for HTTPS. So you can see two request ports, maybe 2 browsers or 2 tabs trying to access that particular destination IP. So this is how you identify flows by looking at the flow. So the typical flow record can have the IP addresses, source and destination. It can be either IPv4, v6, both. Then they have the port numbers, source and destination for the different ports. Then you can see their protocol types, type of service, byte counts, timestamps, start and end. Then sometimes you might see the interface numbers of the traffic as well if it was defined in your router. So if the router is defined to send the interface number, then it will send you the interface number as well. Then different TCP flags as well as different routing information like AS numbers and source prefixes, if they are again defined to send these details. So this is some traditional image from Cisco books. So first the device will inspect the packet and then it will get the data into a table. So this is what we call NetFlow cache on Cisco. I'm not going to go into detail of this. So NetFlows are currently available in most of the devices, Cisco, Juniper, even HP. Some of these devices, they have SFlow, as I said earlier. So HP, they comes with something called SFlow. And mainly they will be cached on devices unless you export them into some external collector. So we installed NFDump as the external collector. So Juniper, they have their own flow version. JFlows, Huawei, they have their own flow version, but still most of them support NetFlows or either SFlow. So you can use NetFlows or SFlows. So this is the command to see the IP cache flow of the Cisco routers and some of the tags. I'm not going to go into details of the cache, but we need to know about the limitation of the cache. That is, cache is just a cache. It will just put data up to a certain time of period, and then it will remove the data from the cache. Once it removes, or once it refresh, you can't see what happened before. So because of that, it's not a good idea to keep data just on the cache. And the other thing is, it's difficult to read because you just have to go into CLI mode and then do few commands to see what is happening, and that is one of the main issues we might see. Okay, so that is the limitation of caches. And then to overcome that, we are exporting data, exporting these net flows into a different location. So these are called an external collector. So these collectors can do collection as well as analysis. So it can be a single collector and multiple analyzers, or it can be a single collector and a single analyzer as well. Okay, so before again exporting net flows, make sure you create the required policies. So, why I am saying this is, if you are the network admin of a particular institute, and if your management is okay for you to monitor your network, then that is fine. But if you are a part of a big network which have multiple administrators, or maybe if you are on the top layer of your NREN or somewhere like that, your low-level administrators may have different views on looking into their traffic. So actually these traffic are not your traffic, it will be their traffic. So you will be analyzing their traffic, and they might have different policies on whether how you keep your traffic, or whether you need to look at their traffic, or some other issues as well. So even political issues. So because of these things, please put a policy regarding the retention of network usage traffic, the retention policies, privacy protection, who is authorized to read, how much time you retain these policies, retain this data. And then if you are offloading this data into public, that you should mention that you will sanitize personal data. So by saying personal data, it can be the host IP addresses or something similar. So the sanitization of data is again an important thing. So by net flows, you might not see the actual packet content, but still you will be seeing the calling information. Calling information means where it went and how it went. So these data still can be a privacy issue, because so that please make sure you have the policies before doing the net flow retention. The other thing is, if you have multiple virtual servers, sometimes these virtual servers might have different MAC addresses, or maybe the same MAC address for multiple VMs, or maybe the same IP address for multiple VMs. Because of that, sometimes you might feel it's impossible to differentiate traffic data from the VMs. So keep that in your mind as well. So if a particular IP is a NAT IP, then you might not see much visibility into the user side of that IP. So it's similar with the VMs. So most of the time, these net flows will be used to verify whether something has really happened, whether someone really accessed something. So if you have these policies, you will be okay to do whatever the reporting you want based on whatever the findings that you do. So make sure you have these policies and make sure make sure this policy says what you can do and what you can't do with this data. So when it comes to NetFlow versions, there are several versions: version 5, version 9, version 6. So this most of these modern devices might have something called IPFix. So IPFix is again these generalized standardization for version 10 of NetFlow. So you can use version 10 IPFix with a lot of other vendors as well, not just Cisco. But if it's version 5 and version 9, it will be mostly Cisco. HP devices, they will have something called S-Flow, and Juniper, they will have J-Flow, but mostly Juniper and Huawei, they will support S-Flow, especially version 10. Okay, so this is how you deploy NetFlow. First, you need to determine which interface you need to enable NetFlow. So that means you are not going to enable NetFlow on in each and every interface of the router. If you do that, then you will double count the traffic, because there for a router there will be an import and an output. So if you monitor both ports, then you will be counting the traffic twice. Then you need to configure the routers, set up the NetFlow collectors, and then configure the applications if you need to do the analysis. So this is a typical image from our example tutorial. So there's a border router. You enable NetFlow on that border router and then export them into an internal collector. And then end users can see, and end user means the administrator can check the application running on that particular collector. Then deciding which interface you want to search, which interface you want to monitor. So for example, let's say the router A will have 3 interfaces, and you need to decide what are the interfaces that you want to monitor. For example, if you want to monitor all the traffic coming from the internet, you can monitor the incoming traffic into the interface that is open to the internet. But let's say if you see NAT, if you do a NAT before that, then checking the outgoing traffic won't help you much, because the outgoing IPs will have the NAT IP as the source or destination. Then the best way would be the other interfaces. In that case, you need to enable NetFlows on both these interfaces, which opens to part B and part C. So it depends on how your network works. Most of the time, people will be monitoring the interface that is open to the internet, but still it depends on whether you want to monitor whether you want to detect the NAT IPs. If NAT IPs is there, you have to monitor the internal interfaces. I hope you got the point. But make sure you don't count interfaces like this internet and one of the internal. If you do that, then you will be double counting some portion of traffic. Then minimum, it's like minimum requirement will be based on your network, but for me it will be like something like this, maybe an i5 PC with more RAM, 4 GB RAM or more, with more space. So more space means more retention time. If you want to keep this data for several years, then you need a lot of space. Okay, so NFCAPT, dump is the open source collector for Linux. So it will be the daemon for listening for this traffic. So NFCAPT by default listens once it is installed, and then it will create new files every 5 minutes. So these, depending on your traffic collection, the size of these files can be from several kilobytes to several gigabytes, but it will change every 5 minutes. Then NFDump can be used to read these files. So these are two application, NFCAPD and NFDump. NFDump can use to read these NFCAPD saved files and turn them into human readable output. So NFCAP is a command line application, and it have a lot of filters and aggregation ways of reading flows. So this is kind of a idea from NSRC. So routers and the traffic, and the NFCAPD, they collect the traffic, and then NFDump, they read the traffic. Then NFSend is the web front end for NFDump, where it will give you the RRD based graphs. So you can have a nice colors, and you can have nice visibility into your data. So normally NFSend should allow you to navigate through data and then create different profiles and different alerts based on the data. So this is another example. So NFCAPT creates the flat file, and then NFSend reads these data and put it into different graphs. So that is what we saw from the earlier NFSend NG, where we try to see the TCP data, UDP data, ICMP data, likewise. So this is the NFSend configuration, which I'm not going to go into details because we were not configuring NFSend, but it was NFSend NG. But this is for the traditional NFSend tutorial. So these are NFSend graphs, some examples. Then the detail page, NFSend and NFSend NG. From the detail pages, you can see the source and destination hosts and ports. You can filter them based on the IP address and based on the port numbers. You can see unidirectional and bidirectional flows as well. And then different protocols and different other details. So they can be checked and they can be filtered as well. So these are some of the example measurements. The first one you can see few IP addresses in mixed format, the top 10 addresses ordered by bytes for a particular time period. And then the first one contains both IPv4 and IPv6 data, but the second one you will see only IPv6 data because it is filtered to show you only the IPv6. Then little on something on net flow analysis. So before doing the analysis part, you should know about the network. Net flow is how you, or the flows is how the traffic communicate from one system to the other. So for that, you should know about your system, how data should come from one place to the other. So if you know that thing, then once you look at the net flows, then you can get a high level idea on what is happening in your network. Then using net flows, you can easily identify different anomalies, and then it might have some IDS capabilities as well. So you need to enforce policies, you need to see what are the services that is running in your network, who are running those services, what are the open ports, what are the closed ports, whether there are any internet open services. For example, let's say you are providing public IP addresses to your customers, to your staff in your customers means the staff in your institute. There can be a particular staff member who hosts a website in his PC, and then maybe he might be doing some illegal data transferring using that website. Maybe let's say they are hosting a torrent website, or let's say they are hosting some sort of website that contains a lot of implicit images or content. Then if something goes wrong, and if some issue comes because of this sort of a website, the first thing the law enforcement will look is who owns the website. If you are the admin and if you provide the website, if you provide the IP address, then they will directly come to you thinking you are the responsible person for these websites, but you don't know anything about that. That is because there's a random guy in your network hosting something without your knowledge. So these type of things can be identified easily by looking at net flows. So if there is a unknown IP address that has open ports or open services on common ports like FTP or HTTP, HTTPS, then you can check what these are and why they are open these ports. So before someone comes and tells you that there is something happening in your network, you can identify these by looking at this sort of data. Okay, so planning and policies needs to be there if you need to do it in a successful manner. So you need to have the policies established. You need to establish specific pathways or gateways where you need to know what are the traffic that going along with that. Like SMTP, proxy, etc. So if you have these things, then if you have the policies and if you do the planning properly, if you if you segregate different servers and different workstations into different subnets, then it will be easy for you to do the monitoring and even the measuring. And then the flow size, you can always look into the flow sizes and identify whether there are any issues in the network, whether there are high usage and whether there are low usage. So you might not get a good idea as soon as you set up this system. You need to give several weeks or several months for this system to get to create a baseline on traffic, on data, how it works, how your network works. So maybe the first few weeks, first few months, you might not see much on these traffic, or you might not gather any intelligence from these traffic or on these graphs. But once it gets old, once it becomes old, or when it have some sort of a baseline, then you can identify the changes or the fluctuations of the pattern. So for example, if we take the second graph to the right side, you will see a pattern. So every day during the daytime, you see high traffic, high number of flows, and then the night and the morning have a low number of traffic. So this is the baseline. So that is how your normal network works. Every day during the daytime, it gets high flows, and then later on it reduces. But let's say suddenly you see a peak on a night, or maybe a sudden peak, a sudden drop during the daytime. That means there is an issue, or there is maybe a downtime there, or maybe some network issue, maybe someone doing some, or maybe an attack happening in the night period, or maybe let's say you see a continuous traffic from the morning to night, or maybe up to several days. Then that means maybe someone attacking you. If it is an upload, then most probably some of your clients got infected with some sort of a virus or a botnet, and then it is trying to attack someone outside. If it's a huge download, then it might be some sort of a DDoS type of an attack into one of your servers. So it can be any of these, or again, it can be a torrent seeding lot of gigabytes from your network to outside. So it can be anything, but you need to identify whether it is happening or not. Okay, so from NetFlows, you can identify the port numbers, source destination addresses. Based on these addresses, even you can identify the country which this traffic comes as well. Again, you can count the flows and count the bytes as well. So for example, let's say if there was a torrent seeding for several days, you can simply use the NFN or NFDump to calculate the IP address and the number of bytes based on the timeline. And you can put a report saying this person did something like this and it cost 100 gigabytes or 1000 gigabytes per single day, something like that. Okay, so this is one of the common examples we take from our installations. So even in this example, I am masking some of the IP addresses. That is because I am sanitizing user data. So the masked IPs are some user data. So because of that, I am masking them. So you can see, so the scenario was there was some high traffic from a particular institute, and we need to check what is happening. So when we do the net flow, you can see the time period. It's from it's like 4 days time, approximately 4 days in 2017. So this during that particular period, there was two devices having that much of gigabytes, and you can see the number of flows in millions, and then gigabytes, number of gigabytes. And then we check the other IP addresses. You can see the other IP addresses. So the other IP addresses, they belong to some public services. So because of that, we neglected these other IP addresses. But we were looking for the top two that is marked. So when we check for the particular top uploads for that particular day, so the earlier one, it was like the all, it's download and upload both, but now it's the uploads. So the first one, it will give you the uploads. So from the uploads one, it was just those two IP addresses, and even from the those two IP addresses, one of them had a high number. So the other one was okay, it was just 8 GB, and when we checked, it was a website. So we assumed, okay, so 8 GB is okay for whatever the content they had. And then we narrowed our search into the particular IP address. So when we check the particular IP address, you can see there are a lot of zero port traffic, UDP zero port traffic from that IP to multiple IP addresses. So here you can see the aggregation of traffic. Zero port traffic was like 60 GB, and there was another port having around 50 GB. Why port 0? Why port 389? What is port 389? So port 389 is the LDAP port. So if you are an IT administrator, you know what is LDAP and how much of traffic an LDAP should consume during four days. So LDAP, it's like if it's using a database of thousands users, it will be few kilobytes per a session. So even if you increased it with millions of sessions, it won't be like 50 gigabytes for 4 days. So this is not LDAP, but something that using LDAP port. Then why port 0? What is port 0? So port 0 is normally used for ICMP, and again the same time some applications use port 0 to do data transfer. Again, some channels like IRC, they do port 0 data transfers, but in many cases, port 0 is being used by different botnets. So ultimately, we asked that particular administrator to check into that IP address into that host, that particular device. So it seems to be a Windows Active Directory running in the public IP. Normally, we ask not to put Active Directories into public IPs. So they were somehow doing something with this Active Directory, and actually one of the researchers were using this particular Active Directory from a different location. Because of that, they had to keep it on public network. So somehow someone got into the network, and then they used that particular Windows device as a botnet. So that is what has happened. So the story ended like that. Okay, so we actually we couldn't do much after the incident because it was we know what has happened, so that researcher doesn't have to do anything even there. So we can blame the administrator for not putting any firewalling mechanism into that server, but still we couldn't do much because of the policies we are having at that time. But in case of you, if you have a proper policy, you can simply try to do something that is effective in these cases. Okay, so these are some of the example filters you can use with NFSen. You can type this in the NFSen. There's a box on the NFSen page where you can put the filter. So there are some examples. I'm showing you how to install. So for example, if you want to filter only the IPv6 traffic, you can simply type INET6 or IPv6 or a similar expression. Then for TCP, UDP, OICMP, DRE, etc., the IP and then the IP address, if you need to do an IP address, IPv6 and IP address if it's a IPv6 address. Then the network subnets, source and destination. So the source and destination words are optional. If you want source, then SRC space net. Otherwise, you can just put net. Ports, then the TCP flags, different hosts. You can check flows with byte count, whether they have high number of byte counts. Likewise, so there are a lot of filters. So some of the examples. You can try these examples. And then this is some example coming from the internet. So how to identify a worm. So it depends on how the worm works. So this is an example of how they did. So what they looked was they checked the high flow count and then the low packet count, number of high flows with low packets. So this is like if the stations generate other traffic, it can obscure the worm activity. So there are high traffic coming from some entity, but the high traffic is like there are a lot of flows, but with small content or 3 packets. So that is a kind of way they try to identify the worms. And then email virus detection, multiple mail messages per host in the same flow. Then mail going directly to the border instead of authorized servers. So if there are like multiple, if there are mail servers in your network, you should only allow those servers to go send emails. If you allow all the IP addresses in your network to send emails, then the internet will blacklist other internet mail systems will blacklist your IP addresses, and ultimately your whole IP block saying you are sending spam. So if a particular device gets hit by a botnet, or if a particular IP address get infected by some sort of a spamming virus, it will try to send emails to the internet. So it will ultimately get blacklisted. Your IP will get blacklisted. If that happens in a regular basis, email providers, they will ultimately block your whole IP address range. So what will happen is even your legitimate emails will get into spam, or it will be bounced. So your clients, your staff, they will start complaining that their emails are not working, they are sending spam, and there will be a lot of issues. That's why most of the time our administrators intended to go into email systems like Gmail and Microsoft, and then they block the port 25 from outgoing. So they can't, so their users can't put anything on port 25. So if you block port 25 from your routers, then it will stop sending spam. But for different services, like the different applications that use different emailing facilities, they might still need to have this port 25 open. So make sure that is regulated properly. Otherwise, all your IPs will get blocked. So that is where you need some sort of a policy enforcement done, especially with email sending. So this is again another old example from the internet where they did an iframe exploit. So you can read this and see how they try to detect Trojan. So this is the example traffic. Since okay, so destination port is here. You can see the 23 has this table have gone on the side. Okay, yeah, still have some issue, but yeah, but now you can at least read it. So these are the source IPs, the destination IPs. So we did the experiment. So this is the Learn Lab IP, the 645, and you can see how it goes. So what we are going to do after detecting something. So now here we have a local IP, and then we have a private IP, multiple private IPs with a local IP. So the local IP is having a sort port of like 3585 and then a destination port. So what is happening? So the IPs, so we have, so here you can see there are three sets that been identified. So once that has happened, you can identify the common IP who is doing the exploit. So in this case, 10, 10, 10, 23. So you can ban the IP from the network if you can't connect, if you can't figure out what is happening. So the easiest way is to block that IP from your layer 3 network and then isolate it later on to figure out what has happened. And then again, if you want further clarification of what has happened, you can simply go through the entire log for that particular day and see what has happened. So sometimes it can be something coming externally into that particular IP and then starting going from that IP to the others. So most of the time, there should be some sort of an external entity accessing your internal IP, and then later on your internal IP starts sending something outside. So in that way, you can identify who actually sent whatever the virus or whatever the thing that happened. So in that case, you can simply block that particular IP that was coming from the first place. So to find that, you need to read the whole log of that particular day or maybe even few days earlier. So it can be happening for days. So you have to find the first occurrence of that incident. So it depends on how much time you retain data. So that's why we ask you to at least keep data for a month. So normally ISPs, they try to keep these net flows up to 6 months because of different code procedures. But as an administrator, you can also do the same thing. So it helps you to be safe, be on the safe side if some lawsuit happens. So it is the easiest way to stay safe. Okay, so other types of detections is like there can be different spywares. You can search how to if you suspect a particular spyware, you can search the internet on how to detect them. So they will have different traffic patterns. Then you can simply find what is happening in your network. So there will be different DCMA reports, attack reports, scanning reports. So if you are the administrator of a particular IP range, then you will receive multiple reports regarding different scans from a particular IP. So if you want to verify them, you can simply use the NetFlow logs. Otherwise, let's say if you didn't have any NetFlow log, then what will happen? You can't find the proof of whatever they accuse. So these reports may say different things, but you need to first check whether they are correct. So to do the testing, you need to have some sort of your own log. So NetFlow will be one of the main things that you can have for such detailed finding. And then once you get these details, once you verify these details from NetFlow, you can do access controlling using firewalls or any other controlling device in your network, or even blocking a particular user from your network. So to do that, you have to first verify whether it's actually happening without just relying on an external report that was sent to you. Okay, so there are several references that you can do. Any questions on NetFlow? Okay, so once a victim is banned, the word victim might not be the actual word to identify that. So it can be a victim or it can be the actual attack as well. So we don't know about that. So first, what you do is you bang that IP, or if you can find the MAC address of the particular device, the best way to bang is using its MAC address. Otherwise, if they change their IP address, they can again log into the system. So try to find the try to find the MAC address for that IP, and then block the IP and MAC both. Once you do that, then try to find the actual device which belongs to this IP and the MAC. So since you will be the institute administrator, you have the capacity, you should have the ability to investigate a such situation and try to find the issue with that device. So I I am not sure how it works in your scenario, so you need to relate it into your way of working. So that's why we should have particular policies saying if something goes wrong, if something like this happens, the user should allow the IT people, IT person to do the troubleshooting and do the error finding. So if that is there, then they have to allow you to access their device. So sometimes, let's say let's say this happened to a very old professor. They might not like to give you their laptop or their PC to access. So it depends on the PR skills as well. So once you get the access to that particular device, you need to find what is happening and then try to resolve it for them if it's a victim. But if you think that person is the actual attacker, then you need to put a complaint on management saying this guy is doing something like that. For an incident like the one I took earlier, someone hosting a website purposefully in sharing something that is illegal can be an issue for the management as well. So you have to come from the top side to remove that. Yeah, so with BYOD, yes, it is a big issue when it comes to BYOD. If it's BYOD, then most probably it will be on wireless. And if you block the MAC address, then they can't again log into the system. So ultimately, they have to come to you taking their device. So if it's let's say if it's a student who doesn't know anything on IT, most probably it can be that person can be the victim. So then you can simply help them by cleaning that device and helping them, or at least telling them what to do. And later on, you can remove the ban on that particular device. Yeah, so since we do 5 minutes sampling, there can be a chance of missing some of the flows. So it's not just the malware, but it can be any, even if you are using NetFlows for billing, still you might lose some of the data because of the sampling rate. Then if you have resources in your collector, resources means the RAM and hard disk, then try to reduce the sampling rate to maybe 1 minute. So once you do the 1 minute sampling, you will receive a lot of data, but then you will receive a lot of insights of your data. So that is the only way of doing that. Otherwise, you have to do it inline. Inline means then it's not NetFlows. It's just you are doing the IDS thing. What else? So regarding NetFlow collectors, the easiest way to install a collector is this NFSen and NFDump. But other than that, you can use the Elasticflow with Elasticsearch. And then there's something called Prometheus, the difference between Elasticsearch and Prometheus is Elasticsearch, they will have their own licensing schemes. You need to buy their licenses if you are going to do large data analysis. But Prometheus itself, Prometheus is an open source system, and you can use it for free even with big data. Only issue with Prometheus is still we don't have much documentation on NetFlow analysis, so you have to do it by your own. So if you are aware of, if you know how Prometheus works, you can simply install Prometheus, and then the analyzing or the UI will be something called Grafana. So you have to install Grafana and then do the analysis of NetFlow. So those things have to be done by your own, because still there are very much low documentation on Prometheus. Any other questions? So there was a question asking whether we have to upload data to Elasticsearch separately rather than sending the collected data. No, actually, once you create the Elasticsearch, so the way of collecting logs is called Logstash. You can create a direct Logstash for NetFlow, so you don't need to install nfdump or nfsend. For that purpose, you can directly use Logstash to collect NetFlows as well. Yeah, so I forgot about the softflow-D. Give me a minute, I share my screen. So this is one of the testing FreeSense I did, and so we have enabled something called softflow-D. So softflow-D is the application or the plugin that supports NetFlow. So in this case, you can see I am selecting WAN. So in this installation, there are three interfaces: LAN, WAN, and a DMC. So I'm just selecting WAN, and then here you need to provide the host of the collector, IP address of the collector, and then the port address. Then other than that, most of the time you need to mention what is the NetFlow version. So you can simply select either these three. Mostly NetFlow 1 is not used anymore. I'm not sure about what SAP is. I am not that much aware of that. But NetFlow 10 is there. And then other than that, there's nothing much you need to do. You can simply add these values, the host IP, collect IP, collector port, and then NetFlow version. So if you are familiar with pfSense, please go with soft flow D, and it will be easy for you to identify traffic if you are doing net flow analysis. And again, pfSense doesn't have much good reporting capability or even the monitoring capability, so it's better if you can go with soft flow D and sending those traffic, those flows into a different collector and do the analysis there. Any other questions? So there was a question asking Power BI related application. Sorry, I am not that much aware of Power BI because I'm not a good Microsoft user. But if you are capable of doing the analysis part, you can associate Power BI to do the analysis part. And then there was a question asking whether we can use Google Analytics for net flow analysis. I'm also not much aware of whether we can do, whether we can use Google Analytics, but I just searched the internet. There are several ways of doing it, but still you need to have NF dump and then sending the data into Google Sheets for the net flow analysis. So that is one way of doing it, but I'm not sure whether they have all the capability of all the flexibility in doing the analysis. So if you try that, please let me know also. So actually Learn recruited a new data engineer very recently. I think we can ask from that person as well about Google Analytics and NetFlows. I'll try to put that to her and see whether she can do something on that. And if I get anything, then I'll come back to you as well. Okay, so if you don't have any questions, we can stop the workshop for today. Yeah, so there was another question asking Google products, whether there are any other Google products. Yeah, so there's something called Google Studio, but Google Data Studio. We have used Google Data Studio for some analytics, but I haven't checked it with NetFlow, so it will be the same. So it's the question will be how you connect your NetFlows with Google Sheets. So if there is a clear connection between those two, then yes, you can use Google Analytics or Google Data Studio for do the analysis. NFDump can be used to send data. NFCapD can be used to send data into a SQL database. If that is correctly working, then you can simply connect this SQL database to Google Analytics and Google Data Studio, so it will do the analytics. But I haven't done that, so we need to check that whether it's working and what are the limitations they have. Okay, so if there's no any other question, we can stop the workshop today. Tomorrow we'll be looking at some of the persona things. I know there is a persona not working in Laos, but I'm not sure about the other locations. So again, we might try to do the installation tomorrow. So it's better if you can pre-download the persona toolkit. I'll send you the link on the chat. Sorry. So this page contains the persona installation, the official installation. On that page, there's a ISO image, a link to ISO image, CentOS ISO image, customized CentOS. It might have around 3 GB or 4 GB. So please try to download it before tomorrow, and I'll go through the installation tomorrow. Okay, so thank you everyone for today, and we'll see you everyone tomorrow morning. See you.